Okay, so the question we're asking ourselves this time is how can you graph a system of linear inequalities? Let's go ahead and dissect this question real quick. We're talking about graphing, and then we're talking about a system, meaning that there's more than one inequality, and linear, meaning straight inequalities. Remember, there's four types of inequalities that we use. There is greater than, is less than, is greater than or equal to, or is less than or equal to. So how do we graph when there's more than one inequality on the same one? If you want to follow along in the textbook, it's on page 274. So look at the instructions. It's saying, tell whether each ordered pair is a solution of the system of linear inequalities. I do want you to take notes on this and label it 5.7a notes. And so let's look at the question carefully. It says, tell whether each ordered pair, so it's going to give us an ordered pair, like here's an x and a y, and here's a -2 and a 0, is the solution of the system of linear inequalities. The system of linear equalities. Remember, a system of linear equalities is a set of two or more linear equalities in the same variables. So you can see there's one inequality here, there's another one here, and they have the same variables, y's and x's, so that's a system just because of that. And so we want to find a solution to this system, and we basically want to find out if this is a solution to it. It's already been given to us. Now, a solution of the system of linear inequalities in two variables is an ordered pair that is a solution of each inequality in the system. In other words, this has to be true for both, okay? Notice that I only have two this time, but in theory, I could have two or more. I could have multiple inequalities there. Okay, let's go ahead and give this a shot. Let's try it. So remember, the first one is an ordered pair is the x, the second one is the y. So let's substitute these in and see what we get. So instead of a y, I'll substitute a 5 for the y. Bring down the inequality is less than a 2, and then substitute in place of the x up here, a 3. Oh, is that true or false? Is 5 is less than 6? Oh, that is true. So far, so good. Now we got to try it with this inequality. So instead of a y, we'll substitute a 5 because 5 is y. Is greater than or equal to, instead of the x, we'll put in a 3 for the x, and then read down the plus 1. Is 5 greater than or equal to 4? Yeah, that's true. So I would say that 3 and 5 is a solution. It's because it works to the system, because it works with both inequalities. Okay, I guess the question I would wonder at this time is it the only answer, or could I put in other ordered pairs that would also work? For instance, if I were to try a 0 and 1, would that also become true? Well, 0 would be, 2 times 0 would be 0. Would 1 be less than 0? Actually, 1 would be, that would be false. So it's not everything works, but there's maybe other numbers that work. And actually, we find out there's an infinite amount of numbers that would work. This is just one possibility. Okay, well, let's try this one and see what we get. This ordered pair. So again, instead of a y, we'll substitute what the y is, which is a 0, is less than 2 times, instead of an x, we'll substitute in what the x is. Remember, this is the x and this is the y. So 0 is less than -4. Well, actually, 0 is not less than -4. Because on the number line, we can see that -4 is more to the left. So this is false. If it's false for one of these two, we already know it's not going to work with the system. So I would already can tell you that -2 and 0 is not a solution. Okay, if you need to watch this again, watch it again. Otherwise, it is your turn to give this a shot. Your turn to try it. In your journals, try this page 274, 5.7a, so it's easily graded by me or my instructional aide. And let's go ahead and try these two, see if you understand it. The answer is either going to be it is a solution or it's not a solution. Go ahead and give it a try.